Today, let's examine how you can use the IBM Cloud App Service to get started building cloud-native applications and deploy to Kubernetes on IBM Cloud. The IBM Cloud App Service offers a guided approach to creating new cloud applications, and it lets you start building your new apps in just a matter of minutes. We'll start by clicking on the Get Started button on the IBM Cloud App Service webpage. The first step is to select the appropriate starter kit based on the application we want to build. There are starter kits available for building both web apps and microservices using popular languages including Java, Swift, Python, and Node.js. In this case, we're going to select the Java web app with Spring. We're going to go ahead and click the Create App button. We're going to give our app a name. We're going to select a resource group. We'll go ahead and hit Create. Our basic project has now been created. And here we have the ability to start adding services or resources. IBM has a host of services that you can use. In this case, let's select a database. And we'll pick Cloudin. We'll select a region, a resource group, and a pricing plan. We'll stick with Lite for now. As you can see, the Cloudin database service has been configured and added to our project. Now that we have this service added, we're ready to set up the DevOps toolchain for Kubernetes deployment. We can do this by clicking on Configure Continuous Delivery. The first step in setting up our DevOps toolchain is selecting a deployment method. We have a few options here. We can deploy to IBM Kubernetes Service, deploy to Cloud Foundry, or deploy to a virtual server. In this case, let's target our cluster. You can select which cluster you'd like to target, and then click Next. Then we can enter a toolchain name, region, and resource group, and then click Create. This will configure the DevOps toolchain and create a private Git repository for starter application code. This process also binds your IBM Cloud services to your Kubernetes cluster so that authentication credentials will be bound to the cluster and available in your Kubernetes secrets. Here we can see that the toolchain has been created and added to our project. Let's click on the View Toolchain button to see exactly what it's doing. Here we see all the tools that were configured in the previous steps. It includes the private Git repository, the Eclipse Orion Web IDE for accessing your code when you're not on your primary workstation, and the delivery pipeline. Let's click Delivery Pipeline to get a detailed look at how it's configured. Our pipeline includes a build stage, a deploy stage, and a health stage. Any changes to the repository's master branch will trigger the pipeline, and the pipeline's deploy stage performs a Kubernetes deployment using the Helm chart that exists as part of the application source tree. You can also click on Add Stage to customize for your needs and your workflows. Now that our project's been created, we're ready to set up our local environment to start developing. We'll do this by copying the project's Git repository URL. Then we can run a Git clone to pull the project locally. I've now opened the project in Visual Studio Code. Here we can see it includes all the configuration and source files that are needed to build and deploy our project. For more information on local development, be sure to check out our other videos on using the IBM Cloud Developer Tools command line interface. Last but not least, let's switch back to our browser and view the Kubernetes dashboard. When I hit refresh, you can see here that our project has been deployed. We can see that our deployment, pods, services, and even the secrets that contain authentication credentials to access our IBM services. The IBM Cloud App Service makes it simple to start building new cloud-native applications. You can get started today by visiting cloud.ibm.com/developer/app service.